Hey, it's Mr. Tupper. Welcome to Solving Time en Route Questions for the FAA Private Pilot Airman Knowledge Test. Just like with every other type of question ever, the first thing you need to do is pull out all the key information from the question. Obviously, you don't get to highlight on the test, but I'm going to do it here for clarity. I suggest taking the stuff out and just writing it straight down the list on the side. In our case, all right, we're looking for estimated time en route. This is our target. And the information that we're going to use to obtain it is our departure from the Allendale County Airport in Area 1 to the Claxton-Evans County Airport in Area 2. And the other information that we're going to pull is that the wind is from 100 at 18 knots, a true airspeed of 115 knots, and we're going to add 2 minutes for climb. So, the way we go about doing this, there are a few pieces of information that we need, because guess what? We're going to cheat. Just kidding. It's not cheating if you're allowed to use it. So we're going to use this thing to work our way through. We'll do another one of these with the manual E6B at some point here, but for now we're going to stick to the CX3 flight computer. We're going to be using, there it is, wind component? Nope. Smarter than that. There we go. Wind correction. There we go. We're going to be using the wind correction section of this, and my suggestion is just open this up right away and make sure you hit clear and clear out everything so you don't have extraneous stuff in there. So there are some pieces of information that we need. We're going to start by just plugging in everything we possibly can. We don't know our ground speed. We do know our true airspeed, 150 knots, so 115. We don't know our true course yet, so we have to go find that. The way we do that is we start by finding the proper figure. In this case, it's figure 23. And then we need to identify the airports that we're going to be flying between. In this case, for a start, we're going to start at the Allendale County Airport in Area 1. So we're going to find Area 1. Hey, look, there's Allendale right there. Then we're going to fly to the Claxton-Evans County Airport in Area 2. Find Area 2. Claxton-Evans. There it is. To find your true course, you got to pull out your plotter. And keep in mind the direction that you're going is important on these. I like using the spinny wheel because it makes it very intuitive. You can use one of the manual ones, but we're going to be focused on the spinny wheel for now. So, thing number one is make sure you are laying your page as flat as you can. Because if you've got a hump, that's going to distort things, and you see if I push this down, it kind of rounds over. So we are going to get this page as flat as we can possibly get it. And then we're going to use our plotter by using the center mark, which I find is much easier for working within this book. So we use our center line right through here, and we make sure that it runs through the center of both airports. So you see it runs right through the center of the Allendale Airport up here, and actually I could even do a little bit better. And it runs right through the center of the Claxton Airport down here. The next thing we're going to do is we're going to use our little cheater lines on this thing right here. We're going to make sure the 0 is pointed towards the top. Also, it helps to make sure that your page is right side up. I've had students make that error before. So make sure your page is right side up, make sure the 0 is roughly at the top, and then you're going to find your latitude and longitude lines. Like here. You're going to find one that shows up inside of the circle here. In this case, we've got one right on the edge here. So what we're going to do is we're going to twist this until it is perfectly parallel, until the vertical lines are perfectly parallel with one of those north-south lines. A thing that can make this easier is if you scooch your plotter up a little bit to make those lines show up in a more easily accessible place. And you can even scooch it so that they're really close so you can really clearly see when it's parallel and when it's not. In this case, that is just about perfect. Now you look at these arrows and you think, which direction are you going? Am I going from here to here, or am I going from here to here? In this case, I'm going from Allendale up here to Claxton down here. So I need to use this arrow down here. I'm going to double check, make sure that's perfectly parallel, and I'm not going to touch it. I suggest you read it right off the page, but to make it more clear, here, we take a look and we see, in this case, that arrow, that black line, ooh, I scooched it. Gotta fix it. There we go. Just doing the same thing again. There we go. That arrow right there, that black line, pretty much perfectly covers 210, then every little tick mark is 1 degree, every bold tick mark is 5 degrees, and the labeled ones are obviously 10-degree increments. So in this case, we're at 213 degrees true. So we know that our true course, which we can write down, our true course is going to be 213 degrees. So when we come back to our calculator here, we can go ahead and punch in 213. Enter. Now we don't have true heading because that's part of what we're going to calculate. In this case, we're not going to need it for this question. We are going to need ground speed though. We do have wind speed. We know that our wind speed is 18 knots. Another common error on these is students punch in the wind speed and direction in the opposite places. Make sure you read wind speed, verify 18 knots, enter. Wind direction is out of 100 degrees, hit enter, and bam, the rest populates. The nice thing about these calculators is you can start by just punching in every piece of information you know, and maybe they give you something. If there's not enough there, try and solve for something that you know you can solve, and then punch that in. And then generally once you do 1 or 2 calculations on your own, you can punch the rest in here and it'll give it to you. So, key piece of information here is that we have a ground speed of 120.83 knots ground speed. So, now we've got to start. But in order to find time, we need to find our distance and our speed. Because if we recall, velociraptor equals distance raptor over time raptor, right? So, what we're going to do is if, for example, we were going from Hampton Varnville here to Allendale, what I would do is I'd take my piece of scrap paper, because they give you 2 of these on the test, and I'd make a mark in the center and in the center on my piece of scrap paper. And I'll make those a little bolder for you to see. There we go. So now I have these little vampire bites. And the scale at the top here, what you're going to do is you are going to set it such that one of your marks falls within this range of little boxes over here. Verify the top one should be nautical miles. Verify that you're reading nautical miles if it's saying you're going to do this math in knots, or you're reading statute miles if it's saying you're going to do this in miles per hour. But you're going to find a place for your mark to the right and set it on a multiple of 10. So in this case, we're going to set that mark right on 10 right there. And then you come over here and do 10 plus, and then count the boxes to the left. So 1, 2, maybe 0.2-ish. So 12.2 nautical miles is how far these 2 airports are apart. So now we're going to do the same thing for our actual route, and again, get this page flat. Set the edge right on, and ideally, you should use a different edge. So I'm actually going to flip this around so you don't get confused for your marks. If you have to do more than one of these, make your marks on different sides of the page. Verify you pass through the center of both. You're going to make a mark at the center of each one. There we go. Now this one's just interesting because we've run into a problem. Those marks, if we compare them to the scale, are longer than the scale. So, what we do to solve this, take your piece of paper and fold it, and make your marks line up perfectly. So you see on one side I've got the one mark, on the other side I've got the other mark, and fold it so you got a nice sharp edge. just like that. So this right here, from the edge of this piece of paper to my mark, is exactly half the distance between those airports. Now that's something I can measure, because that actually fits. So again, I'm going to find a multiple of 10 to put my edge on the right on, so that my mark on the left falls in this range of little boxes. So I can pull it down, and I can see that this reads 20 plus 1, 2, 3, 4, and there we go. We'll count properly. 1, 2, 3, 4, 5, 6, 7, 8 and a half. So half of our distance is 28 and a half nautical miles. So now we can do 28.5 times 2, and we know that our distance between these two airports comes out to 57 nautical miles distance. There we go. So now it's really easy. You can either do the math manually by dividing your distance by your ground speed, or if you want to be lazy, you can come up here to ground speed, hit enter. It'll even have the ground speed that you calculated from somewhere else. You can punch in your distance of 57 nautical miles, and you get 0.47 hours. Now, you'll notice that doesn't make our answers happy yet. So what we need to do, two things. Number one, we need to make sure we do not forget to add this 2 minutes. So I'm just going to put this in here so we don't forget. Now we need to convert our hours to minutes. So 0.47 hours, multiply that by how many minutes are in an hour, so multiply that by 60 minutes, gets us 28.2 hours. And now it's as simple as just adding minutes. Add 2 minutes plus 2. Hey look, now we've got a nice square answer, 30 minutes.